Hi everyone, we are going to solve this limit problem. The goal is to solve for the limit of omega when r goes to 0. And the problem is constructed in the following way. We start with this green circle C1 with center 1, 0 and with radius 1. Then we take a bigger circle C2 with radius r, and we take the intersection point of these two circles and call it B. And now the question is, if we connect this point A to B, we pass a line through it, and we take the intersection point with the x-axis, we get this point C, omega 0. And the question is, if r goes to 0, so this white circle shrinks to the origin, what will happen to the limits of this point? The steps we will take is we will first, of course, calculate b, then try to express omega as a function of r, and then take the limit when r goes to 0 of this function f of r. And we hope that isn't too hard. So first, let's calculate b. The equation of the green circle, C1, will be x minus 1 squared plus y squared equals 1. Now the equation for the second circle will be x squared plus y squared equals r squared. Since r is the radius and it is centered at the origin. So now we need to solve for the intersection between these two circles. So let's subtract the second one from the first one, and then the y's will cancel. And we get x minus 1 squared minus x squared is equal to 1 minus r squared. And now we get x squared minus 2x plus 1 minus x squared is equal to 1 minus r squared, which gives us that minus 2x is equal to minus r squared, which gives that x is equal to r squared over 2. Now let's plug in x to the first equation to calculate y. We get that r squared over 2 squared plus y squared is equal to r squared, which gives us that y squared is equal to r squared minus r to the fourth over 4, which is 4r squared minus r to the fourth over 4. So we get that y is equal to the root of 4r squared minus r to the fourth over 2. So now we have both coordinates. We know that b is r squared over 2 and the root of 4r squared minus r to the fourth over 2. So now it's time for step 2. Now for the second step, we are going to express omega as a function of r. And to do this, we have to calculate this point CW0. So let's first calculate the slope of this yellow line. Let's call this m. This will be equal to this y value over 2 minus this y value, r, divided by this x value minus 0. So this will be equal to 2 divided by r squared over 2, which is equal to the following. So now the equation becomes y equals this slope over r squared times x plus some value. But if we plug in 0 for x, this point A has to lie on this slope, so we get that this value has to be r. So to calculate omega, we have to plug in y equals 0. So 0 equals this whole thing times x plus r, so that x, which is equal to omega, is equal to minus r divided by this, so we get minus r third divided by so this is our result. F of r is equal to minus r cubed divided by the square root of 4r squared minus r to the fourth minus 2r. That means we can go to step 3. So we conclude that if this r goes to 0, the limit of this point is equal to 4, which is very unintuitive. I would have guessed 0 or infinity. Don't forget to like and subscribe.